Okay, so last week we talked about the subprograms and we experienced how the subprograms are working. And today, as I told you, we are going to talk about the evolution of the programming languages, some theory parts, right? And how these programming languages are working, right? Like what's the impact? What is the way that they are going to work inside the computer, right? So to understand that, you have to understand how a programming language, or like what is the journey of the programming languages from the beginning of the computer. All right. So at the very first days, like when the Ada Augusta Lovelace, the first programmer, was programming through the punch cards, right? What they were using to feed into the computer as the instructions, they try to insert the instructions into the computer as ones and zeros. The reason is the process of the computer understands ones and zeros. So they were trying to produce the instructions in the form of ones and zeros. Like it's kind, we call it a bit stream, like a collection of one and zeros. And this was not quite easy work, right? And they have to create a punch card to feed these things into the computer. So the holes inside the punch card indicates as zeros and the non-hole places indicates one, right? So they create this punch card and feed the instructions into the machine. So since the machine is receiving ones and zeros straight away, like in other words, the machine language straight away, right? Like machine language means ones and zeros, the instructions in ones and zeros. Through the punch card, since the machine is receiving the things, the ones and zeros, I'm sorry for the disturbance, people. So since ones and zeros, the machine language is straight away fed by the punch card. The computer could understand that instructions very easily, because ones and zeros are the language that the processor can understood. So we are feeding the instructions in a way that the one and zero is represented using the punch card in the very old days of the computer. So it takes the instruction straight away, so it could execute it straight away, right? So there is no need for that particular instructions to be wait until some other preparations to be done, right? So because of that, it is very fast in operation, right? So it could be executed directly in the machine, as I told you, and it is very fast in the operation, right? And they do not need any translations, because translation is needed when some instruction, like when non-binary instructions are there, to be converted into the binary, right? So using the punch card, it's the ones and zeros that is providing. So no need of translation, straight away understand what's a one and what's a zero. And the disadvantage is it is heavily depend on the machine. Like that means, like if the same program to be manufactured or to be made to another particular computer, they have to go through the same, or like the same amount of work, not the same pattern, the same amount of work of putting that ones and zeros into the punch card, right? Because the reason is, even today, the processor from one computer to another is differ from each other, right? Even though it says some particular brand or some particular model, as an example, let's say all of us is having a processor of i7, right? Intel i7 processor. But my i7 processor is different than your i7 processor. The architecture, the preparation of that microchip is different, slightly different from your one. So it's kind of a keyhole, people, right? Like when we got a key, we can insert that key into different keyholes, but it will unlock only a one specific door. So likewise, once a particular program is written in ones and zeros, it could be fed into a one specific processor, and that particular program cannot be fed into another processor because the architecture is different. So in that case, programmers have to go through the same amount of time, put the same effort to create the same program using a different pattern, which is matches to the processor in the other computer, right? And again, it is very difficult for the human to understand what is written or what is being designed using ones and zeros. They always have to have a reference. This is what is represented by this particular line. This is what is represented by that particular line, likewise. But, and again, it is very easy for the computer or to the machine to understand since it is given in ones and zeros. So that is the era of the first generation of the programming languages. Now, since the man is always searching for something easy, they were always trying to make this task, the task means the task of inputting the instruction or providing the instruction in the computer, be much easier for them, right? So in that journey, later they were finding there is a way that we can give the instruction using small English words, right, which we name as mnemonics, and then ask someone else to convert those English related instructions into a ones and zeros, right? So based on this finding, they have made a programming language called assembly language. So in assembly language, it is a little bit easier for the programmer to read the language, right? And to understand what that they are talking about, or what that particular person need to express, right? Later, when the program is written and asked to execute it, a program called assembler will convert that assembly code, like you could see over here, into a machine code, that means into ones and zeros. Then this particular machine code can be understood by the processor. The one who is involved in to convert the assembly language or the assembly code into a machine code is called the assembler. Right. People, are you clear up to this point? No, that's it. Yeah, that's it. It's kind of like this. When the result is need to be output, there are several different ways that they are going to output it. On these days, they heavily use printers. So of course, once it is processed, it will be again converted into the human readable format and then given to the printer to be print out, to do the printing out as per our use, as per the humans use. Right? It's a good question that you have asked, does it? Right? Yes. So once it is being executed, it's not like the program will be translated again, right? අපි program එකක් පාවිච්චි කරාම program එකෙන් output එක කියලා එන්නේ වෙනමම දෙයක් නේ, right? Like we execute the word processing software. So using the word processing software, we create the documents. Then we print out the documents. But the program is word processing software. So that word processing software is written from a high-level language. And to understand that word processing software by the CPU, it needs to be converted into ones and zeros first. Got that? That's it? Is it clear? Right, great. And now first they had the machine language. Now they had something called assembly language. And the assembler will help you to make it like not you actually. The assembler will help the code to become a machine code or a code which is accessible to a particular computer, right? And later, with the evolvement or like evolving process of the computer languages or the programming languages, there were many different languages happens to be created based on the assembly language or like the concept of the assembly language. So the concept was making the programmers have less effort on the programming and let someone else to translate it into the ones and zeros. So like first they had machine code, purely ones and zeros. Then they had assembly code, had some mnemonics. And there is one other thing that you need to know about the assembly code. Assembly code converts like one particular line of the assembly code into one particular line of the machine code, right? So if we assume there are 5 lines in the code, so in the machine code, there will also be 5 lines, right? So we call it like, we call it as a one-to-one translation, right? So it's kind of a costly way of doing things, right? One-to-one translation. But when it comes to the high-level languages, they had this chance of giving a very user-friendly language or like the programmer-friendly language to the human programmer and ask the machines or like ask the particular computer to convert that thing into the machine code, right? So it's the same thing that has done in the assembly language. We are writing the code in assembly language and then we are asked it to convert into a machine code, right? So the same thing happens, but the difference is when it comes to the high-level languages, they will be translated in 2 different ways, right? And whatever the translation that they are going through, that they are using, one particular line of the source code will be translated into many particular lines in the machine code, right? So like let's just simply think about one thing inside a particular program. So that program, if the program that they are using is what we call the assembly language, it is a little bit closer to the programmer friendly part. So it will convert one particular line into one particular line of the machine code, right? So one particular segment will be represented as 1010 something something. And when it comes to the high level languages, there are 2 types of things, and the major difference is one line of a high level language will be converted or like will create more than one particular line in the machine language, right? So a simple instruction, as you can remember, if we write a simple write ln, so we say write ln within brackets, we are going to say something like hello, right? So when it comes to the machine code, that particular line will be converted into ones and zeros heavily, right? So that is the major difference of the comparison in between high level and low level programming. So as you can see in this picture, 00 and the visual languages, right, are there, right? And Photon, C, Pascal, it is there. So those are belongs to the high level language part, right? And the machine language comes at the very end over here. So machine language, from that we can use the assembly language. From that we can go for high level language like Photon, C, Pascal, Python, C#. There are a lot of. So when it comes to the high level languages, that means much programmer friendly languages, assembler was not sufficient to convert these kind of lines in a particular way, right? So when it comes to the high level languages, they use two different kinds of translators to do the translation. One is called the compiler, the other one is called the interpreter, right? So how this compiler and interpreter is working. So when this interpreter is here, what the interpreter is trying to do is he's trying to do a task of a human interpreter, right? So when the task of a human interpreter means, like if I need to talk to a Chinese person, I'm going to hire a translator. So I'm going to tell my particular details to that translator, and translator then later translate it to the Chinese, right? So when the converting process, right, like converting from higher languages to the machine language, there can be another way which we call a compiler translations. So now interpreter, as I told you, it converts one after the other. It takes one, it executes that, and it takes the second one, it executes that. So, but the compiler is not on that manner. What the compiler does is, compiler takes the entire program at once and converting it to the ones and zeros, then feeding into the processor. And so that is the major difference in between the high level language and the machine language type of things. Okay, people, is that clear? Right, great. Okay, people, give me a second. All right, sorry for that, people. And the things I have explained to you, you can see it at the end of this note. We have to talk about the paradigms as well. Regarding the translators, we are just explaining the things over here. So the interpreter, as I told you, program written in high-level language, it's interpreting into the machine language instruction. So it is done like one line at a time. So if there are 5 lines, first line will be read and it will be converted into ones and zeros. Then it will be given to the CPU to execute. Then the second line will be taken, converted into the ones and zeros, and will be given to the CPU to execute. But compiler, on the other hand, is not working like that. He's just taking the entire program and convert into ones and zeros at once, and then given to the CPU to execute. Right? So due to this, the translator, the translator, which is called interpreter, will start the execution very quickly, because when the first line is met with the interpreter, it starts translating. Compiler, it will take time to translate the machine instructions into ones and zeros entirely. So it will be late to start the program when it comes to the compiler. But if we take the big picture, the entire picture, translator or the interpreter will be slow in execution process, because even though it is started the very first way, it has always to take a particular statement, convert into ones and zeros, should give it to the processor. Take the next one, convert into ones and zeros, give it to the processor. But when it comes to the compiler, compiler takes the entire code, convert it at once into ones and zeros, then it is given to the CPU to execute. So due to this, the interpreter starts the execution first, but end it with a delay. But the compiler will be delay on starting the program, but it will end it before the interpreter. Right? Did you got the point, people? Okay.
It's so yummy.
Yeah, Udamya, let me explain it to you again. Hold on, Dua. It's like this. So I'll give me this time. I'll come and So assume this is your program.
Dad.
So it has 5 lines.
Even that person give me chocolate.
Okay, good. That is your truth is here. Go and talk to him. And when it comes to the interpreter, I indicate him from the I. So what is it doing is it will take this first line into that and then convert it into the ones and zeros. Next, the second line will be taken, converted into the ones and zeros. Like so, like converted into the ones and zeros means it can be given to the processor. But if this is going to happen using the compiler, compiler will take the entire program in and convert that into ones and zeros. So there will be a lot of ones and zeros, right? Right, so the entire program is converted. Then it will give to the execution for the processor. So due to this, this is going to, the interpreter is going to start first. Right, this will start first. This has a delay start because it needs time to convert. Right? But the ending, the interpreter is going to have a delay end. It takes time.
Do you like this mushroom?
Okay, so yes, Manika.
It's a polka dotted one.
And the compiler, it is ending.
Pineapple.
It is ending first, or like ending at the first place.
Do you like to eat bananas?
Yes, so. Udama, did you get that?
Kiwis. Kiwi.
Right. Okay, great. Right, so I will end this and come.
Really
Yeah, we'll discuss, right?
It's so pretty.
Mm-hmm.
How beautiful they are, aren't they? Do you want to?
Yes, people, I'm sorry. Thank you for the notification. Right. So people, what I was saying is, like, that is the journey of the languages from the machine language to the high level languages. Like when we consider the machine language to the high level languages, machine language is purely designed out of ones and zeros. Assembly language is like in a very small manner, it is being supported with the English letters and words, and it is still much closer to the machine language, and high level language is much closer to the human language. So this machine language and the assembly language, right? These two things, these two categories are called low level languages, and all other things apart from that are called high level languages. So first we had machine language, next we invent the assembly language, which needs an assembler to do the conversion into ones and zeros. Later we found the high level language, which we use interpreter and the compiler as the translators of the high level languages into ones and zeros. So that is the small picture that we have to remember. Okay, are we clear with these people? Okay, great. Right, now I'm moving to the paradigms. Right, so now there are something called programming paradigms. Now paradigm means it is a complex concept to understand. Now we are just discussing it in a very minor way, right? We are just brushing what is programming paradigms are. We are not going to deep tensors or like deep concepts here. So when it comes to the programming paradigms, now first of all you have to understand what is a paradigm means, right? It describes over here many different approaches to computer programming are called programming paradigms. So like you know that, right? Because we can have several different approaches to one particular solution, right? When we are trying to build up a solution, we can like have that solution in many different ways, right? So those many different ways are called programming paradigms, right? So when it comes to the programming paradigms, two major sectors are there. One is called the imperative programming paradigm, and the other one is called the declarative programming paradigm. So imperative and declarative are going on two separate ways, in two separate structures, but at the end they will be producing you the same output or the same satisfaction, right? So how these things are different from each other, right? So before that I have given you the diagram or the table which is in your textbook, right, which divide the things into the imperative algorithmic and the declarative ones and the object oriented ones, right? So there are some different kinds of programming languages lies over there, right? So you really don't need to remember what these things are, but just get to know there are like these kind of things. So there are imperative ones, there are declarative ones, and under the declarative one, there are functionals and logical ones, and there are object-oriented ones. Just only those hierarchy will be enough for you, right? So they have specifically talked about the difference between the procedural and the declarative paradigms. Now, I have given you some explanations over here, but you can clearly identify the procedural and the declarative paradigms just by looking at this picture. Right. So the procedural paradigm, it is talking about how to achieve a particular solution. Now, in Pascal, we went with this procedural paradigm. So in Pascal, we have to say one by one to the Pascal programming, or in our case to the Charm Pascal, we have to instruct it one by one how to achieve something. Right now, think about the program that we have done. So we have done a program we take a particular value from the user and we decided whether it is an even number or an odd number. So we have to instruct the Pascal, we have to tell him how to take a particular value from the user and how to memorize it, reading into a particular variable, and then how to decide whether it is a odd number or an even number. We said like take the number divided by 2 and we should consider the remainder. We use different kinds of operators. Then using if structure, we compare what's the value of the remainder. So based on the value of the remainder, we just instruct the Pascal, okay, if the remainder equals 1, you output even number. If the remainder equals 0, you output even number. If not, you output odd number, right? So likewise, it is not that easy for the programmer, like comparatively, it is not that easy for the programmer. So programmer have to have a good effort on the program to instruct what to be done. So it's something like what you can see in the picture at your left hand side, right? So you are given 3 different blocks, and then you are asked to build up a pillar. right? So according to the procedural paradigm, we have to tell, okay, take the block A, keep the block B at the top of block A, and keep the block C later at the top of the B. So then you will be finding a pillar. But when it comes to the declarative paradigm, programmer's effort being reduced, right? So programmer is just instructing, right? He's just saying what the programmer wants. Programming language itself is trying to build up a solution according to the user requirement. So according to the declarative paradigm, if I need to create a pillar, I'm just telling to the programming language, you just make me a pillar. Here are the blocks, 3 blocks are there, you just make me a pillar. And the program itself is going to figure out what block is going to be at the bottom and what is going to be at the top of it, and then what is going to be at the top of next, right? So that is the difference in between procedural and declarative paradigms. Are we clear about that, people? Yes, everyone? Right, very good. And next, we are going to talk about the structured and object-oriented paradigms. It's another different kinds of paradigm. Now, in our Pascal programming language is a structured paradigm. So with that, you can identify one particular programming language is not just belongs to one particular paradigm. It can represent many different paradigms, right? That's the way of the programming paradigms, right? So when it comes to the structured and object-oriented paradigms, in structured paradigms, we have a specific structure of achieving our solution, right? The structures that we have learned, the selections, the iterations, the sequences, right? Those are the structures that we can use. So we know when to start and what is the way of flow, and when we are going to, whether we are going to meet a condition or not. So according to that condition, are we going to do a selection or are we going to do an iteration? Then what we are going to do, so and so, we know what is the flow of it. So it is well structured from the start to the end. So that when a programming language has that kind of an approach, we call it, belongs to the structured paradigm. And when it comes to the object-oriented paradigm, it's quite different. Now, again, object-oriented languages, object-oriented programming is something which is going deep in a different approach, right? Now, from this, only from these points, you cannot have an idea about the object-oriented programming, but just have this idea, people, right? In object-oriented paradigm, or like when it comes to the object-oriented programming languages, it behaves in a different manner. For all the object-oriented programming languages, they have this component called class, right? Now, as an example, I have given you here, I have taken a class called car, right? So these classes have methods and attributes. Method explains what are the things it can be done. Attribute explains what are the components that class is having, right? So if I need to create a particular program regarding these methods and attributes, so I have to create the objects based on the class that I have defined, right? So these particular objects, as you can watch over here, Polo, Mini, Beetle. So these 3 objects are 3 different objects. They may have common factors as well as they may have specific factors for them as well, right? So likewise, I can create the objects once I have defined my class, right? So using those objects, I'm going to make my program. right? So simply what you have to remember is object-oriented paradigm refers to the component called class, and from the class we can create objects, and inside a class there are two different things called methods and attributes. Methods describes what are the things that the class can do. Attributes describes what are the components that belong to that particular class. Are we clear with this, people? Yes, everyone. Don't just go for overthinking on this topic, because it's definitely a new and a complex topic for you. Do you just got the idea that the object-oriented languages or the paradigm having a particular thing called class, and you can create objects out of that class? Then again, the class consists of what do you call the methods and the attributes. That is all that you need to remember. Yes, are we clear, people? Yes, everyone. Can you hear me clearly? I suddenly dropped the responses, people, it seems. People, can you hear me clearly? Okay, January, that's great. All right. So that will be the story regarding the paradigms, right? So we discuss about two particular paradigms, which is procedural and declarative, and the other one is the structured and object oriented, right? And there is another small concept called programming and scripting, right? So programming means it's kind of like it says, there are hard and fast syntax rules in programming languages, right? So when we have programmed something, we should compile it to understand it by the computer, right? And when it comes to the scripting, it is much into the interpreting procedure, right? Like the languages like JavaScript, PHP, like both of the things are web-related languages, right? We call it scripting languages. They have a certain building blocks kind of components. So we have given a particular component. So out of those components, we have to create the model that we want. So we can say, like, when it comes to the programming, it's kind of a clay ball that is given to us, right? Yeah, Sasrika, PHP means hypertext pre-processing. They are not abbreviating it as HPP. Sometimes they say like pre-hypertext processing, but generally it says hypertext pre-processing. We use that to do the database or like the server-side programming when it comes to the web, right? Web design and all these things. You can learn PHP if you take your A-level career with ICT, right? We are teaching PHP with the 10th lesson for the A-level ICT people, right? So now what I was saying is, like, programming language is kind of a clay, right? Mati wage. Like when we have the desire, we can make whatever we want as we want, right? In our shapes, in our way, we can create it. And the scripting languages are like building blocks. Like, even though we need to create a ball out of building blocks, we won't be able to create a ball as we want, right? If you want to create a clay ball, you can create a ball shape from a clay very nicely and very smoothly. But if you are going to create a ball from the building blocks, it will be quite hard. Like, it may look like a ball, but not that look like a ball, right? So that kind of an approach is there when the programming and scripting take place. And remember, programming is much better with the compiler, and scripting is much better with the interpreter translators. Okay, so that comes to an end of the first lesson, right? So those are the only theory parts that we have to discuss. So I have sent you the note, all of your WhatsApp groups. So you can print it, you can download it and refer it, right? Even you can share these things, and these contents are taken from your textbook, right? So it will save the time, like of writing things on your book when you are having this kind of note with you, right? So that is why I am preparing this and handing over to you. All right, people. So now let's try some questions regarding this, right? Some O-level questions, right? So let me take some O-level papers for you so you can experience how the things are going on with the paper, right? So let me take the 2007 English medium paper. And meanwhile, if you got any question regarding the programming, you can ask. Okay. All right, people. Now the question that you can see it on the screen, it is the third question of the 2007 paper, right? So the first question that they're asking is, write down the output generated by the following flow chart, right? So the flow chart is given here, right? Let me reduce the size a little bit. Okay, try to figure this out, people. I'm going to work this for you within, let's say, 5 minutes, right? So try to figure out. They're asking you to write down the output generated by the following flowchart. Give it a try. I'll give you 5 minutes to do this. Okay. Udamya has said an answer. We'll see Udamya. Okay, Dinalka. We'll see whether it is going to be the correct answer. Good that you people are like doing this, right? I'm very happy that you are trying these things. Okay, Behara. We'll see. Okay, Sasrika, we'll see whether it is going to be the correct answer. Can we try this now? Do you need any more time? Anyone who needs more time? Otherwise, we can try this out. Okay, so let's try this out, people. I'll take a screenshot so I can edit this easily. Right. So as you can see, what we are trying to do is what we are trying to do here is called the hand tracing, right? Without doing the hand tracing, we won't be able to figure out what is the output for a particular flowchart or for a pseudocode. And people, can you hear me clearly? Can anyone confirm? Do there any volume reduction or anything? No problem. Right. Thank you very much. Thank you very much, people. Right. So what are we going to do here is like we are going to start first, right? Hold on. Yeah, we are going to start first. Then it says x equals 1. So whenever we are hand tracing things, whenever we are met with a particular variable, it's better we maintain this type of table saying what's the value of x. So the value of x is 1. So that means this step is done. Then it says display x. So when we are hand tracing to each and every variable that we are finding, we create it this kind of column, as well as for any output, we are going to create another new column. So I'm going to put or mark this as the output. So according to my output, it says display X. That means I'm going to show the value 1 because the value of X is 1 for the moment. And then it says X equals X plus 1. Right? So that means this X is going to be promoted as 2. Then the question is asked whether X is larger than 5. So the value of X is 2. 2 is not larger than 5. That means this condition is false. That means it is about to go on the no path. People, are you clear until to this particular point? Great. Okay. So then what we are going to do is, so going on the no path means, right? Going on the no path means it comes over here. Then it's going to display X again. Now the value of X is 2. So the output will show you 2. Then it will increase the value of X again. That means it will become 3. So then it checks the condition. Still the condition says X larger than 5. So X is 3. 5 is not larger than. So it goes on the no path again, which brings us to display X again. That means we are going to display 3. The program is going to display 3. And increase the X by 1. That means this 3 will become 4 over here and checks the condition again. Still the condition is false because 4X, which is 4, is not larger than 5. And again, it's going on the no path, which brings us to display X again. That means we are going to display 4 again. Increase X by 1. That means 4 is becoming 5. And again, it brings us to the condition. So now it is asking X is larger than 5. The value of X is 5. Is 5 larger than 5? Yes, people? Is 5 larger than 5? No. That means we are going on the no path still. And it is asking us to display X. That means we are going to display 5. And we increase the X by 1. That means this will become 6. And now we comes to the condition. So the condition is asking whether X is larger than 5. So what about the condition's answer now? Is it yes or a no? Yes, Sasrika, it is a true. That means it is a yes, right? So that means it goes on the yes path, which will reach us the end. So the question is, they are asking write down the output generated. So what's going to be your output? The one that you can see on the output column. This is the output that you are going to generate. Okay, are we clear with it, people? Is that clear? Right. Good. So let's discuss about the next part, right? Here I'm showing you the next part. It is just another output that you need to generate. So the pseudo code is given and some data is given in this table. And here as well, they are asking what is going to be the output, right? So let's say the question yeah, the following part of the pseudocode, which is used to evaluate the final grade achieved by the student in examination based on the average marks obtained for 2 subjects. The name and the marks for the subjects are as follows. Yeah, the question says at the right, at the bottom, write the output of the above pseudocode for each of the students. And be very careful, they are asking you to write the output of the students, right? So you have to be considered about the output. No, Sasrika, you don't need to draw any this kind of table. Sasrika ahane table එක ඇඳලා පෙන්නන්න ඕනද කියලා උත්තරේ ලියනකොට no, your answer is only the answer which I circled from the green, right? So මේ green circle එකේ තියෙන විදිහට answer එක 1 2 3 4 5 කියලා ලියලා පෙන්නනවා නම් you will be given the full marks, right? Okay, people, can we try this? So here's the question, and they're asking you to write the output. Be very careful because there will be many calculations for you to be done, but always concentrate about the output, what to be there in the output. So write only the output. I'm giving you another 5 minutes to do this. So it's 3:39. By 3:44, I'm going to discuss this, right? So meanwhile, you can send me the answers if you figure this out, right? Okay, give it a try. Give it a try. Yeah, I'm sorry, I was out for a little while, and yeah, yes, many of you have sent me some answers. We'll see. Yes, okay, Pehara, Denuka, Osanda, Udamya. That's great. We'll see how it's going on. And we'll give some 2 minutes for others as well. Then we'll come to that, right? All right. So yeah, I'm getting a lot of answers, people. I'm very happy of this. Okay. Do you want any more time? Do anyone want any more time? Or can we go for the discussion? Okay. So let's move to the discussion. So I'm going to take a screenshot as usual. Okay, so it says set average to 0. So according to our practice, it's better we maintain a table. So I'm getting average. It's better I write the entire name, but since I am out of room to do that, I'm just keeping the AVG to indicate the average, right? Then I have name and marks for the subject 1. So I maintain as S1 and marks for the subject 2. I'll maintain it as S2, right? And in here they says average equals subject 1 plus subject 2 divided by 2. Yeah. So that means what they are going to be fed is like from these records. This is the first record that they are going to consider. So the name is going to be Arthur. Subject 1 value is going to be 40. Subject 2 value is going to be 80. Right? So average is equals to 40 by 80 divided by 2. That means 120 will be the total. Divided by 2 will going to give you 60 or 60.0. It doesn't matter. You can have it as 60 or 60.0. And that is from this particular place. And from if condition, what they are asking is whether the average is larger than or equal to 50. So if this condition is true, what's going to happen? This is going to happen. And if it is false, then it comes to the else part, then it's going to show this. So anyway, like per any record, either this is going to be output or this is going to be output. Not both the things are going to be there. So now our average is 60.0. That means 60, which is larger than 50. That means it's going to give us the output of pass. But before that, we are going to have the name as our output. So if you think about the output is going to be what? The name will be there, which is Arthur. And then there will be the word called pass, right? So it says display name, comma, pass. So it's better you put Arthur and put a space and pass, right? Why? Because if something shows within inverted commas, that means output it as it is. Output. But when we are outputting it, we are not going to put these double quotes. Program double quotes to indicate or to give us a meaning, saying output it as it is. So it's better we say Arthur space pass. And some of you have send me the answers by separating it from a comma, which is not incorrect, but it's better you go with this. Some have sent me with the dash. Some have sent it with the double quotes. Not that they are incorrect, but it's better you go like this. So since the if condition is satisfied, it comes only to this particular statement and it's not going to come to this. So the first output is going to be after pass. And it ends. And this is going to be the second input. And these are separate inputs, people. That is another thing that you need to understand. We can't find any iteration over here. So Arthur will come and provide his record and see what's his output, and the program will end. And then Bertie will come, provide his details and see his outputs. What's going to be his output? Bertie has 60 and 70 as his values. So 60 plus 70 is 130. 130 divided by 2 is going to give you what? Yes, 65. Yes. So we are going to have 65. And he is passed then, right? Because in the condition, it says if average is larger than 50, display name and pass. So the first one, I'm sorry, the second output is going to become like Bertie pass. So likewise, now you know what the pattern is. Next one that you are going to have, Charlie pass. Is he pass? Can he be a pass student? Because Charlie is having the total of 100 and divided by 2, it's going to give you a 50, which is not larger than 50, but it is equals to 50. So still, Charlie is going to be a pass one, and David is a little bit unlucky. And he got 80 as his total mark, so the average mark is going to be 40, which is not larger than 50, as well as not equals to 50. So he says fail. Right, so this is going to be your output. Right, I'm glad that most of you, the people who have sent me the answers, like almost all of you have taken the correct answer. That's very good. Okay, so let's try another. I'm taking you to the O-level paper 2008. Chanuri, you don't need to write the table, doer. It's only the output that you need. So the thing that I have squared, only this thing will, this is going to be your answer. This is the only thing. You don't need to go with the table. Table is for your rough works. Right? Okay. So let's go with the 2008 paper. And I think it's the same question. I will go with the MCQs. Yeah, quickly tell me what's the answer for this. Yeah. What's the answer for this? Yes, Pehara, Udamya, your answer is correct. Sasrika, Denuka Chanuri, you have to go through all 4 answers. I think you are a little bit panic with the answer. Osanda, same goes to you. Dinelka, that answer is correct. Very good. Yeah, Denuka, yes, now that's the answer. All right, so the question says, the logical structure of the flow chart given in the figure question 30 shows a sequence. Does it have a sequence, people? It does, right? Like the things, what happens one after the other. That means these instructions shows a sequence, right? And does it have an iteration? Iteration, how we are going to figure out that iteration? If we go on the flows, it will show us the iterative manner, but here we don't have an iterative manner. We have a particular condition, and according to the condition, it is taken into 2 parts, and later those 2 parts are crossing again. That means it shows a simple selection. That brings us, which calls the third one as the answer, right? Both sequence and simple selection can be represented here. Yes, is that clear, everyone? All right. Okay, let's look into what? All right, second paper. There you go. Yes, okay. So people, give it a try. It's almost 3:57. Yeah, why don't we try the very first one? The first part of the 4th question. Give it a try. And there's a part which is missing over here. I'm going to write the value. This is going to be, yeah, x plus 2, right? X equals x plus 2. Okay, Udamya, yes, that's a good try. Yes, yes. Okay, Denuka, yeah, that's correct. That's correct. Udamya, that is correct. Pehara, that is correct. Very good. Osanda, I think the last value should be changed. Just think about it again. Yeah, Sasrika, that is correct. Osanda, yes, now it is correct. Right, it seems quite easy, right, people? And yeah, how we are going to figure this out? Careful, you will get hurt, Suzu.
I'm not so hard.
Careful.
I'm not so hard.
Okay.
My name is Lucy Lockett.
Okay.
The riding superhero crocodile.
Okay, it will hurt your lips, Suzu. Right, people. So they are asking, figure question 4 shows the flowchart that displays odd numbers in a certain range, right? The first 3 and last 2 numbers displays by it. Right, Dinelka, yes, your answers are correct, though. Right, so what's going to be the first value? So it starts, I'm sorry. It starts, it says x equals 1, all right? So I'm taking the x, so it is equals 1. It says display x, so I'm going to take my output and display 1. X equals x plus 2, right? Let me clear the annotations over here. Right, x equals x plus 2 happens. That means x will become 3, right? Then it checks the condition, whether x is larger than 100. So it is not going on the no part, right? And moves to top and comes to the display x. That means 3 is going to be displayed, and then increase the x by 2 again. So this 3 will become 5. And it checks the condition. Still the condition says no. Goes on the no path again. That means I'm outputting not 3, but 5. So that's going to be the first 3 things. So now you can understand how the things are going to happen, right? So the things are being printed, like odd numbers are going to be printed. So after 5, it will goes on like 7, 9, 11, likewise. So it is talking about, the condition is talking about less than 100. So if it is less than 100, if we need to determine the last 2, it says the first 3 and the last 2 numbers. If we need to determine the last 2 numbers, it's better we come up with a value like 95. Let's say the value x is taking value 95. So let's say 95 is displayed. So here it is being displayed, right? And now x value will be increased by 2. So 95 will become 97. And checks the condition. Condition is false, goes on the no path and shows the x. That means this has happened. Then again, x will be increased by 2, which is 99. Checks the condition again. Still goes on the no path and showing 99. That means this is happening again. And x will be increased by 2. So 101 will be the value of x. And checking the condition, now it is years. X is larger than 100. So it goes on the years part and it ends. So this is going to be my first 3 outputs, and these are going to be my last 2 outputs, right? So people who have sent me the answers have figured this out very nicely and neatly, right? Yes, so that will be the first three and the last two outputs, right? So in the second and the third part, they're asking write the pseudocode that corresponds to the logic given in the flowchart. And the third part, it says state how to modify the given flowchart to be display all even numbers from 1 to 100 inclusive. I'm letting you to do those two parts as a homework. So give it a try, people. I'll send you the message. I'll send you the picture to the WhatsApp group, right? Try it out. Next week, we will be getting a chance to discuss this, as well as we are starting the next lesson, the second lesson, which is a small lesson. Hopefully, we will be able to finish it up within 2 weeks, right? So we'll try our best. And I'll see you on next week for the very same time, right? So thank you very much. And some people have sent me the answers in for the other parts as well. That's good. And anyway, I'm going to see you on next week for the very same time. And thank you very much, everyone. Right? Okay, Denuka, Udamya, what you have sent is correct, Dua. Right? And Denuka, the third part is correct. Yes, that should be the modification. Right? We'll discuss it on next week, Dua. Right? Denuka and Udamya, we'll discuss it on next week. Thank you very much, everyone. Have a very nice weekend. And I'll see you on next week for the very same time.